Okay, this is my second video about simplifying expressions with radicals. For this one, we're going to do more fractions and division problems with radicals. Okay, so I'm going to start with this example. If I have the square root of 9 over 16, I've got this whole fraction, or in other words, division problem under a radical. That's the same thing as if I have the numerator under a radical divided by the denominator under a radical. So square root of 9 would become 3, square root of 16 would become 4. So square root of 9 over 16 simplifies to become 3/4. Now that's your base example. That's basically the property that if I have the square root of a over b, that's the same thing as square root of a over square root of b. So we need to commit that to memory. So we're about to look at another example that's a little bit stickier. I've got the square root of 8 over 12. Now on this one, we know that that's the same thing as square root of 8 over square root of 12 just because of our previous problem. But the problem here is neither 8 nor 12 are perfect squares. So there's a couple of different ways I can go about this. My favorite way is to simplify each radical first. If I come down here and simplify square root of 8, I know that's the same thing as 2 times 2 times 2, or in other words, that's the same thing as 2 square roots of 2. Then, if I take my square root of 12, I know that that's the same thing as square root of 3 times 4, or in other words, the square root of 3 times 2 times 2, or in other words, 2 square roots of 3. So, once we're here, I rewrote square root of 8 as that and square root of 12 as that. I've got a 2 in both my numerator and denominator, so those cancel, and I'm left with square root of 2 over square root of 3. This is a little more simplified than when we were here, but we're still not simplified all the way. And the reason for that is it's not considered simplified until you get rid of your radical in your denominator. So we got to find out how to keep this from being a square root in our denominator. Well, I can multiply by any form of 1 without changing the value of this. I know that I can multiply by 4 over 4, x over x, 11 over 11. All of these fractions are equal to 1. So the way I can get rid of this denominator is if I multiply by whatever this denominator is. If I multiply by the square root of 3 over the square root of 3, I haven't really changed the value of this fraction. I'm going to be able to rewrite a little differently. I know that if I rewrite those under the same radical, that's the square root of 2 times 3 in my numerator and the square root of 3 times 3 in my denominator. Well, the square root of 2 times 3 is just the square root of 6, and then the square root of 3 times 3 is 9, and the square root of that is 3. So this is considered the simplified form of our original square root of 8 over 12 over there. So the things to remember here are, try to simplify your radicals, and once you simplify it as far as you can, if you multiply by a form of 1 using your denominator right here, in this case it was square root of 3, you're going to get rid of those radicals in your denominator, and you have to make it completely simplified.